Here we discuss a problem from complex analysis. The problem is based on an application of Schwarz lemma. And this question has appeared in CSIR-UGC National Eligibility Test held on 26 November 2020. And the question is from the section C and it carries 4.75 marks. The problem is, let D is equal to the set of all those Z belongs to C, the set of complex numbers, such that mod Z less than 1 be the open unit disk, and let F be a mapping from D to D be a holomorphic function. Suppose that F of 0 is equal to 0 and F prime 0 is equal to 0. Which of the following are possible values of F at 1 by 2? The four options are given to us. Let's now discuss the solution of the problem. We are given the capital D is a unit open disk. It is the set of those complex numbers Z belongs to C such that mod Z less than 1 and F be a mapping from D to D is an analytic function. And for each Z belongs to D, F of Z will belong to the codomain D. So since the D is the unit open disk, F of Z, mod of F of Z will be less than 1 for all Z belongs to Z. Why? For each Z in D, F of Z belongs to D and so mod of Fz less than 1 for all Z belongs to D because D is a unit open disk. Given F of 0 is equal to F prime 0 is equal to 0, let us now recall a corollary to Schwarz lemma. A corollary to Schwarz lemma. Suppose F of Z is analytic for mod Z less than R with F of 0 is equal to F prime 0 is equal to F n minus 1th derivative at 0 is equal to 0. If mod of Fz less than or equal to m in mod Z less than R, then mod of Fz is less than or equal to mod Z by R whole power n into m, valid for all those Z such that mod Z less than R, with equality only for F of Z is equal to m by R power n into e to the power of I alpha into Z to the power of n, where alpha is real. Now let us compare with our hypothesis. F of Z is analytic in mod Z less than R. So F of Z is analytic for mod Z less than 1. So our hypothesis is valid for R is equal to 1 and F of 0 is equal to F prime 0 is equal to 0 in our case, and in this case it is up to n minus 1th derivatives, therefore n is equal to 2. In our case n is equal to 2 and mod of Fz less than or equal to m for mod Z less than R. So mod of Fz is less than 1 for all Z belongs to D, that is mod Z less than 1. So therefore m is equal to 1. So the given hypothesis of our problem is the hypothesis of this Schwarz corollary to Schwarz lemma with R is equal to m is equal to 1 and n is equal to 2. Hence, by this corollary to Schwarz lemma, mod of Fz is less than or equal to mod Z square for all Z belongs to D. So, taking Z is equal to 1 by 2 belonging to D, we get mod of F of 1 by 2 is less than or equal to mod 1 by 2 square, that is equal to 1 by 4. From this taking Z is equal to 1 by 2 we get this, and minus 1 by 4 less than or equal to F of 1 by 2 is less than or equal to 1 by 4. So therefore the possible values of F of 1 by 2 are 1 by 4 and minus 1 by 4. And let's look at our options. 1 by 4 and minus 1 by 4 are against the options 1 and 2. and 1 by 3 and minus 1 by 3 are not possible. Therefore, options 3 and 4 are not possible. So hence, the options 1 and 2 are true and the options 3 and 4 are not true. So, and you can see this corollary and this was lemma in a textbook entitled Complex Variables with Applications by S. Ponuswamy and Herb Silverman, and you can see it at page number 281, and it is corollary 8.67. And Schwarz lemma is very important and it has many corollaries, and they find applications in problem solving, and hence concentrate on Schwarz lemma and their applications. I wish you all the best. Thank you.